Day of IEEE for Sustainable Future Summit 2020. I, Aditya Rajiv, the moderator of this evening, on behalf of the team IFSFS 2020, with great pleasure, welcome all the respected senior members, dignitaries, and participants who have joined us for this occasion. Today, we'll be having the most awaited workshop on 3D printing and its applications in the COVID-19 pandemic, held in association with our sponsor Fox 3D Printing. You will get a chance to explore the rapid prototyping possibilities in the current scenario. And I'm also happy to announce that after this workshop, you'll be able to design your own products, and the first 20 and best works of the participants of India will get their designs 3D printed by Fox 3D Printing. All you have to do is get your ideas out and upload your designs in fox3dprinting.in. And I hope everyone has received the instructions to be followed for the same.
Can you please unmute the WebEx?
Yeah. Okay.
Moving on, let me invite Mr. Alif, the Student Ambassador, Publications Team, IEEE PSYP Kerala, to welcome our distinguished speaker, Mr. Sibu Saman, to the event.
Thank you so much, Aditya. Am I audible?
Yes, you are.
Okay, thank you. A very good evening to all. It gives me immense pleasure to witness so many attendees to the technical workshop, a series of initiatives taken up by IEEE PS5P Kerala, and more than that, I feel proud to be a part of myself of the same. We have been through a whole plan of goals that we tend to accomplish, and therefore I would like to appreciate and welcome all the worthy dignitaries to the workshop. I welcome our speaker, Mr. Sibu Saman, a famous fab guru and physicist. He owns masters in experimental physics. He is an integral part in Fab Network, possesses 5 years experience in digital fabrication, and an expert in material science. I welcome you, sir, to this technical workshop. I hope and believe you will be able to train our students quite incredibly. Thank you so much for being a part of us today. Next, I would like to welcome the whole team of IEEE BSYP Kerala. I genuinely believe the intensity of passion that each and every member of the team has to make a real difference and to prove it to the rising youth how volunteering is not just a formality that you take up being university students, but something that stays with you eternally. I am extremely happy to have such an enthusiastic team members. Next, I would like to welcome the IFSF team as they have invested their heart and soul to organize all the sub-events and have always exhibited their energy to organize technically interesting events. I welcome you guys. Next up, I welcome all the student ambassadors of the IEEE PSYP Kerala as well as IFSFS 2020. The curiosity of these young volunteers is indeed an inspiration to all at the moment. The workshops or events are discussed. They are always so curious to be a part of it. So I welcome you guys. Last but not the least, I welcome all our attendees. Without your involvement and participation, no event could be successful. And I hope you all have an amazing learning today. Thank you so much. And over to you, sir. I welcome you.
Hello, can you hear me?
Yes, sir.
Audible.
And you can see my screen, right?
You share it.
Okay.
Please.
Okay, let me know when you share it.
Is it visible? Can you please tell me the WebEx?
Okay, now can you see?
Yes, it's visible.
Okay. Uh, Let me just check one more because in this. So let me play a sample video. Can you see the video properly, or is it not good?
Yes, sir. We can see the video. Also, you need to enable the audio for
No, no, there is no
sharing.
audio. There is no audio.
Okay.
It's just the video.
Okay.
And how about the attendees? Like, because we are sharing the screen and then resharing it. So
It's visible, sir. It's clear.
okay, okay then. I work as a consultant for FAB Foundation. It's an international NGO for for supporting and installation and training in Fab Labs. So I hope you know what Fab Labs are. They are like basically a makerspace for digital prototyping. In Kerala, we have like 2 Fab Labs, like 2 big Fab Labs, and we have like about 20 mini Fab Labs across the state. So I hope most of the students in Kerala at least know what the Fab Lab is. Okay, and yeah, so our session is about 3D printing today, and its application in COVID-19. And since the theme of the event is sustainable future, I will be talking a little bit about that too. Okay, so first I will going to talk about. Can you read the screen? Like, can you see the text properly?
Yes, sir.
Okay. So we are going to talk what additive manufacturing is. Actually, 3D printing is actually additive manufacturing, which is more technically correct word. When we talk about 3D printing, we only like talk about like one kind of machine which we are familiar with, which in a sense is not exactly 3D. There are some of the machines we see is actually printing in one dimension, and another one is in 2 dimension. And I will show you what printing in real 3D is. But for common language, 3D printing and additive, we are going to use it interchangeably. So we are going to talk a little bit about additive manufacturing. Then we will discuss and not in very detail because we don't have much time. So I will briefly talk about the technologies, briefly covering the most important technologies for 3D printing. Then we will just spend like a few minutes on where this technology is going to lead us in the future. And we will also talk about like advantages and disadvantages for additive manufacturing compared to traditional manufacturing, which is subtractive. And also we will talk about like sustainable manufacturing and applications of additive manufacturing in COVID-19. Yeah, let's talk about additive manufacturing. And while talking about additive manufacturing, we have to first define what it is. And all like this is the classical manufacturing method, which is like by subtraction. Like we will remove material. We will start with a big block and then we will keep on removing material until we get into the final object. So as you can see, this is quite wasteful. Like we are removing a lot of materials. It's fast for one object, but if you want to make like thousands or tens of thousands, this is not the method we use. I mean, in fact, even 3D printing is not the method we use for mass production that we know, right? So we would be using something like injection molding or something for mass production. But as you can see, this is wasting a lot of material, and especially when you are talking about like a big expensive engineering material, for example, something like titanium or something for the aerospace industry. We will be talking about like starting with a block of metal which weighs about hundreds of kilos, which is going to cost a fortune. And then we are going to remove most of it, like 90% of it we are just going to remove and send it for recycling. that's not ideal, right? We can start from nothing and we can build it up. This is what 3D printing is about. So the basic process is like you will start with empty like bed, and then you will like keep on depositing materials layer by layer. So there are many ways. You can deposit by layer, and there are recent technologies in which you can build the entire object at one go, which I will talk about in later. And this is actually what we say fused deposition modeling. So we will start with a plastic material, and then we will heat it to melt it, and then we'll extrude it. And the extruder will be moving in XYZ coordinates, and we will like this we will be depositing each layer, and then the next layer will be built on top of it, and then it will adhere to the previous layer. So like this we'll build each layer and complete the object. So this is the basic idea about 3D printing. So this comes from 3D printing. So like when we talk about printing, we know what the normal printing is, like paper printing. Imagine that the ink in the paper has a thickness, say 0.1 mm or 0.5 mm, and when we like stack hundreds and thousands of such layers, we will end up in an object which is like centimeter or 50 centimeter tall. So that's the basic idea. In fact, one of the 3D printing technologies is actually laminated papers. I will show you one of the videos for that. Okay, now yeah, so how will we start with the design? So yeah, obviously you will need a design in computer. You have to design a 3D object in computer, and then the next step is actually slicing. I mean, but it's similar. Like this is, I mean, even though it's funny, like it's something that is very easy to understand. So each of the bread, you can say it's like a thin slice of what the final bread loaf is, right? So each of the slice has a thickness, and the slicer software. So first, suppose we are designing the model of the bread in computer, and then we are going to slice it, and each of the slice we will stick together, and then we will slowly build up the final shape of the bread. I mean, to that. So I will show you one example. Oh, can you see the screen now? With a ball inside a cube. Is that right?
Yes.
Okay. So this is a design. So basically, a spherical ball inside a cubical structure. So, like as you can see, traditionally, this is very difficult to make out of a solid block. I mean, it's very difficult to get into each and every corner and remove the material. Maybe you can do it by positioning the material in like 5 or 6 different ways and attacking it from different angles. Maybe it's possible. Okay. Now, in 3D printer, what we do is like we will slice into many pieces. So this is a slicer software. There are many software. There are even in like for example, this is one of the web-based slicer. Now this is a portable like desktop slicer. So let's slice it, and then you will see that this is each of the layers. So this is how it will start building. So this is the first layer, and then it will print the second layer, and then the third, and then the fourth, and it will slowly build. So this is how we are going to build it. Okay, as you can see, right here, let's say right here. So all the material you can see. Okay, this is the first layer. It's going to build on the base plate, which is going to be like a heated piece of glass or aluminum or something, and then the second layer, and then the third layer. So every other layer you can see is built on top of the previous layer. except for this one, like right here. So you can see that a layer is appearing in the middle of nowhere, like it's air. You see there is nothing under this layer. So this is where we need something called support material. Okay, so yeah, so like just going into like construction field, we know what support and support material is. So when we do concrete work, when we do the roof slab, we need support material, right? We will do form work for the concrete, because we cannot pour concrete in the middle of nowhere; it will just fall down. So in 3D printing, similar. So what we do is like we will go here. By the way, I'm showing this because at the end you will need this when you like design your own object and send it to 3D printing. So let's say everywhere, and then I will regenerate it. And then you will see that a new green layer appears, and this is not layer. You can see the other layers are like very dense, but this new layer is not that dense. So it builds a scaffolding on which then the spherical object is being printed. So what happens is, since there is a scaffolding, this spherical object is not going to fall anywhere. And this also going to give support for this vertical beam, horizontal beam over here. Okay, so yeah, let's move up. And now let's talk briefly about the technologies available. So the most common technology we are familiar with is extrusion. So basically we will extrude material. Okay, and we will extrude maybe plastic. So this is one of the render where you will start with a plastic material. It could be PLA, it could be ABS, it could be nylon. There are many materials. It could be TPU if you want flexible material. So there are many options. So this is one of the animation from Stratasys. Stratasys is a big company. I mean, one of the company who is very early into 3D printing. So as you can see, this is depositing the material and then the support material. So there are, you can see that there are two material with two different colors. Support material, as you can see, this white is support material and the black is actually the object we are printing. This is the one we need, and we will later remove the white portion. So you can see that we are removing support material, we do some post processing, and we will end up with a very nice material. And now this is another, I will show you another time lapse. It's another render, similar technology. And then now when we talk about 3D printing, we usually talk about like plastics and sometimes metal, sometimes ceramic, sometimes concrete. So this is another material which we don't usually consider for 3D printing. So this is glass. You can actually print in molten glass also. Technology is the same, just the machine is going to be a bit more complicated to handle the heat of the glass. So this is the same technology. We are going to print, deposit the glass, molten glass, in layer by layer to develop the final object. So when we history of 3D printing, I don't want to spend a lot of time on history of 3D printing. This is not a history lesson, and it's not going to be very interesting. But at least we all think that 3D printing is a new technology which is like revolutionary and all, but the fact is that 3D printing has been here for a long while, maybe at least since 1970s. The problem was that all the technology was proprietary with license to only few companies. They were ready to share with anyone. And recently, like since around 2000s, the patents got expired. Many of the patents got expired. And then what happened is like a lot of the private researchers and other independent universities, they all could start working on the 3D printer, researching and developing and creating new technology, new machines. So this is what happened. So 3D printing is not a new technology as we see. some of the technologies, some of the methods are actually new, but the technology itself is not very new, it's very old, but we just didn't have access to it. So it was only accessible through like multi-million dollar machines from big corporate companies. So yeah, this is another extrusion based 3D printer. As you can see, this is concrete 3D printer. So this can be used to make housing colonies like houses, buildings, and other structures. And this is just another video. He's building a statue of himself, and the sand here is the support material. So similar to the one before, like they were using a different type of plastic as a support material, but here concrete is the main material, printing material, and then the sand is the support material, which can be easily removed later on. Okay, and another technology is liquid additive manufacturing. So here it's similar to the one before, but instead of like solid object which we turn into liquid, we will start with a liquid object, and then so this is a silicone material, this is ceramic material, but then this is not hardened immediately. So the silicone we will have to vulcanize it, and the ceramic we will have to bake it in an oven for the full strength. Okay, and then moving ahead. So now we are going into a different type of technology. So remember I told you like this is not exactly 3D printing, like in a different sense. So you can see that any given instant, what we are actually printing is what we are processing only one pixel, or like a one dot, and that is at a one dimension, right? We are not creating one line at a moment. At any given instant, we are only generating one dot. So we could say that this is a one-dimensional printing. Now we will go into something called polyjet, and this is actually what I would say is 2D printing. Now the reason is like it's similar to inkjet printer. It's very similar to inkjet printer, except that we are depositing a lot of ink, which thickness. So basically the head is that of an inkjet printer. So the technology is the same. So you can see that it's spraying very like droplets, and each of the drop has a thickness, and it's a UV curable resin. The ink is a UV curable resin. So they will deposit a layer, and then when they pass the thing, so you will see there is a blue light, which is actually UV light. So it will cure the ink immediately, that layer immediately, and then the next layer will be built on top of it. So the reason why I am saying that this is a two-dimensional printing is you can see that we are not processing one dot at a time. In fact, we are processing a line at a time. So this is actually one-dimensional printing. Sorry, the one before I made a mistake. The one before with a dot. This will be like a zero-dimensional printing, and now we reached into one-dimensional printing. So we have a line. We will be printing a line at a time. So this technology is like very versatile. Like you see, since we are using liquids, liquid resins, we can have like different type of resins. We can have like flexible resin. We can have very rigid resin. We can mix in colors. So this technology can actually print in many different colors. You can have flexible, you can have rigid material, you can have transparent material, you can have conductive materials. You can modify the property as you wish. It's a bit expensive. The machines are a bit expensive. For example, the printer we commonly see, for example, this one is you can buy it for around 50,000 rupees, or like under 1,000 US dollars. This is like these machines, it will go something like $50,000 or up to $50,000, maybe starting from in fact, one of the machines from Stratasys is about $500,000. So yeah, these are very expensive machine, and it doesn't make sense for the maker space to have it. but it can do a lot of things. It serves into medical industry, it serves into prototyping for big companies and all. So there are many uses for this. In fact, like, so you can see this a valve over here is printed as such with a gasket, a rubber gasket over here. And the entire thing is, I mean, you don't need to assemble it. It's printed, and you take it out of the printer, and then you just do some post processing, clean it, and then you get a fully functional part, like with all the movable, all the seals, everything. Yeah, so that's something very interesting about this machine. Now, next tech is VAT polymerization. So this is where we actually get into 2D printing. Not at the moment, but I'll tell you. So VAT polymerization is similar in the sense that it uses the same material as before. It uses a photoresin, which reacts to UV. Like when you expose it to UV light, it hardens. So what it does is, like, this is a bath of UV resin, and now we are going to print. We are going to expose it selectively, and then the bed will go down. A new layer of resin will appear on top, and then it is exposed again. So slowly we'll be building each layer. And now this is a printer which is like a small desktop, around $3,000 US. So it's from a company called Formlabs, and you can basically see what happens. So there is a laser beam, and then there is a scanning using 2 galvos. It scans in X and Y direction, and then the bed goes. Previous machine, it was going down into the resin. Here it's going up. That's only different. Basically the process is the same. So you expose one layer, you build one layer, and then the build platform lifts up to bring the new uncured resin to the bottom, and then it's exposed again. So all this webbing you see is support material. You can remove it later. So this is how. So this is called SLS, stereolithography process. Okay, and as you can see, this is very slow. Like, again, this is one dimension, right, or 0 dimension. You are processing one dot at a time. Okay, now let's see this one. So the one we saw just before is using laser, but you can also do it using LCD and DLP technology. So instead of generating one layer, like by line, what we do is, like, we generate the entire line at once. So it's similar to a projector technology. In fact, it's actually a projector inside, but instead of visible light, we use UV light. Okay, so yeah, as you can see, DLP is like exposing the entire layer. So it's just like a DLP projector, and LCD is also exposing the entire layer, and it's just like an LCD projector. I'm not going to so DLP projector uses a micro mirror device, and LCD, as the name implies, just uses an LCD. The advantage is that laser machines have like very high resolution. DLP is okay resolution. I mean, high enough resolution for all the most common jobs, but it's kind of expensive. LCD is very cheap. LCD panels are also very cheap, and but they don't last very long. They are like very the LCD, the material inside that creates LCD is very sensitive to UV light itself, so not going to last very long. Like you can see, this is how the laser thing works. So using 2 galvo, we scan the entire surface, like line by line. So this is why it's very slow. And now this is, so all the technology till now is like very old. It has been here for a while. We just have access to it recently. Now this is a technology which is like very recent, and in fact this technology is only available to like big companies now. It's not produced in a mass scale so that everybody can have it. So it's similar to the DLP or LCD projector. In fact, they use a DLP, but the difference is in how it is being printed. The difference is in the chemistry. So you can see this is very, very fast. This is only 2 minutes, 3 seconds. Now this 3 minutes. It's very fast. So I'm not going into depth of this technology. So it's called continuous liquid interface production. You can search about it. It's marketed by a company called Carbon 3D. So basically, it uses a special resin which is sensitive to UV. At the same time, it will not react in presence of oxygen. So they have a special membrane underneath which is permeable to oxygen. So when they expose it to UV, it's not going to cure. So like you can see here. So this over here, the build platform and the tray in which the resin is kept, they are actually in very close contact. So when you expose the resin to the UV, it will adhere to the layer before and also the tray. So you have to lift it up and then you have to expose it to the new uncured resin. That's a problem. Since the membrane is permeable to oxygen, the resin very close to the membrane is not going to cure even when exposed to UV. That's how they do this printing very fast, because they can continuously lift the print, and as they lift, the new material will be like seeping into the cavity. Now, so we have seen one dimension, 0 dimension, 1 dimension, and 2 dimension. Now this is the real 3-dimension printing. Okay, so this is similar to like a CT scan or an MRI scan. So this is very advanced technology. This is not very easy to understand, like with the common sense. So as you can see, the entire object is getting developed in 3 dimension in real time. I mean, we are not generating one layer at a time. We are not generating one pixel at a time. We are generating the entire object at once. So this is like the replicator in Star Trek movie. The entire thing is getting exposed and developed at a single go. This is very interesting, as you can even have material inside. So this is a screwdriver. So you can see that this object is developed all at once. And this is a screwdriver with a metallic bit inside, and the material is being printed around it all at once. So what it does is, like, this is a computational process. So what we do is, like, this is similar to the previous technology, but we have a projector and then we have a photocurable resin. In fact, the photocurable resin is like very high viscosity, and the solid object, the hardened object is going to be of similar density to the liquid object. So when the exposed resin hardens and when the print develops, it's just going to stay in the middle of the liquid, and it's not going to fall. So yeah, you can see this is printed in the middle of the liquid, and it doesn't need any support material because it's not going to fall. It's the same liquid, same density, so it's not going to fall. So the idea is, like, we are going to expose it, we are going to rotate it, and we are going to expose it with the different images as viewed from the sides. So it's basically a little bit of complicated computational process. And so this is the real 3D printing. We are printing the whole object, the 3-dimension at once. Okay, now another technology is, like, we will start with a powder, and then we spray like material which will glue the powder together. So, and this can be, we can print metal, we can print plastics, nylon, ceramics, we can even print sand, a lot of materials using this technology. So we will start with a bed of powder, a layer of powder, and then we will be similar to the polyjet printer, but instead of the material, we are actually spraying some kind of glue, which will bind the material, bind the powder. And similar to polyjet, we can have a lot of control over the material property. So we can control the so there are two materials, you can see fusing agent and detailing agent. So using these two materials, especially using the detailing agent, we can control the different properties like color, elasticity, translucency. We can even have a conductive detailing agent, so we can have a conductive final object. And so this is another machine which is actually printing in sand using sodium silicate. So sodium silicate is liquid. It's a water glass. Commonly we call it water glass. And when we expose it to carbon dioxide, it's going to be solid. It's just going to be like very. It's just going to be silica. Okay, and this is how we are. So you can see this is a mold for casting metal. So the mold is actually printed. Sorry, the rest of the video is not working. Sorry for that. So this is the mold for the metal casting, and this is commonly used by like automobile manufacturers. This is how they are going to cast the engine blocks and everything. Okay, so and also this technology can also be used for printing metal. So how they do is like you will start with a like metallic powder, and then you will print like a binding material, which could be like starch or something. And then but then this object is not going to be hard, not very hard, but then you will have to put it in a oven, in a furnace, to either sintering, or you have to impregnate it with a another metallic alloy. For example, if you are printing in steel, you can impregnate it with bronze, for example, or brass. So this brass material, this will diffuse into the print. It will adhere. It will make the final object very hard. This is another technology. So what you are seeing over here is a metallic powder, and instead of printing jetting a material like a glue material, what we are actually doing is, so there are two different ways. You can either use laser or you can use electron beam. So we use this electron beam or laser to sinter the material or melt the material and bond it together. So using whether you use electron beam or laser, or depending on whether you are melting the material or just sintering it, there are three different technologies. One is electron beam melting, direct metal laser sintering, and selective laser melting. So there are three ways you can do it. All three technologies here, it will look almost the same. It's just that there are some minor differences. Now this is laser melting, selective laser melting, and as you can see, this is very similar to selective laser sintering. There are not much difference here. And the electron beam process is slightly different. So the bed and everything will just look the same. You will use electron beam to melt the metallic powder and fuse it together. And this is done under high vacuum and inert atmosphere. You can actually build a lot of very complicated material using this technology. So You can see there are like very complicated structures, which is very hard to create using traditional manufacturing process, which is CNC milling or machining. Maybe complicated material designs you can actually print. So this is another process, but instead of the metal, it uses plastics. So this is a sample created by one of the affordable laser sintering machines, which is called Fuse One from Formlabs. So they use nylon material and they use laser to selectively fuse the material. And then now we'll talk about a few other technologies. So when we talk about printing, we usually consider this as 3D printing. But in fact, this is also 3D printing. So it's just like instead of fused material, we are using bricks. That's all. Instead of concrete, we are using bricks to create material. So this is also kind of 3D printing. You can consider it as a 3D printing. This is an animation. And this is the real machine. So it's building a house like brick by brick. So even though we don't consider this as a 3D printer, but this is actually also. And remember, I talked about like laminated paper. So this is a printer. So it creates the object paper by paper. So yeah, it just put a paper and then it bonded it, and now it's going to cut it. So it's going to bind each paper to the previous one using glue, a particular pattern of glue, and it's going to cut the material wherever you don't want it, and then the next layer will be built on top of it. So it's like paper by paper we are going to, and this is the final object. And we remove everything, and you see that this is in color, and the reason is that since it is paper, you can along with the glue, you can also have an inkjet, the normal inkjet head, so which can actually print the color you want. And this is another laminated sheet process. So it's called ultrasonic consolidation. So instead of paper, we use metallic sheets, and we bond the metallic sheets using ultrasonic. So yeah, so you can see that each sheet of metal is bonded to the previous one using ultrasonic energy. So it basically disturbs the oxide layer, and like a solid adhesion forms. So this is, other than that, this is very similar to the previous technology, like printing using paper. Just that the method used for adhering the metal is slightly different. That's all. The technology is basically the same. And now this is a different kind of 3D printing. So what you see here is a jet of metallic powder. Yeah, we inject a jet of metallic powder into a laser, and it immediately melts and fuses at the spot. And we use this. It's similar. I mean, except the method for creating the molten metal, this is very similar to fused deposition modeling from 3D printing. So yeah, so this kind of printer is a what we say hybrid machine. So it will have traditional machining capability as well as 3D printing capability. So it creates the object, and then it does the final final surface machining. We don't have to start with like a big block of material. We can, as you see, this is the material removal is like very minimal. The material wastage is very minimal. We are not starting with a big block. We are actually approximately printing the rough material, and then removing only maybe like a 10% of the material. This is another version of it. So it's actually printing honeycomb triangular patterns. So it created a shell and it created this honeycomb pattern around it for external strength. I will talk about this later. This has an interesting property. And this is another technology. And this is, as you can see, this is very similar to like a welding. So it's just a MIG welding machine. 3-axis CNC machine. So it's generating the final 3D machining layer by layer using the MIG welding torch, and then the final finishing process going on. So as you can see, there are many different ways of 3D printing. It's not something like very new or like a very advanced technology or something. So all these things are, you can see, very simple technology. We had these technologies before. We didn't have the right to use it, because the rights and the patents were with the corporates. That's the only difference. And this is another method which creates plastic fiber composite materials. So this is glass fiber, and it's extruding glass fiber along with the UV curable resin, and it's bonding to the like right then, and it's creating the final. So this is another. So this is all the technologies, different type of technologies for 3D printing, and there are even more technologies. I'm not going to cover all of them in very detail. This is just the general introduction to basic idea for the 3D printing available 3D printing technologies. So any doubts so far before going ahead? Hello.
Hello, sir.
Yeah.
Sir, there was a question in the chat box. I'll read it out.
Okay.
Here's a question from Mr. Jayakrishnan. What material you will recommend for watertight enclosures which need to withstand pressure of a couple of bars?
So that question is a bit complicated in the sense like it also it's not just dependent on the material, it's also dependent on the technology we are using to print it. So if you are using a traditional 3D printer like one of the Ultimaker or like one of the fusion depositor, one of the plastic filament based ones, it's very difficult to make it watertight. So you will have to print it, and then you will have to coat it with some kind of epoxy or like polyurethane based resin to actually watertight. By nature, that printing technology is porous. Otherwise, you will have to use something called something like steel SLA printing, like resin printing, one of the resin based 3D printer that can actually be watertight. And depending on the wall thickness, it can be very hard. And especially if you use materials like nylon, it can sustain a lot of pressure. I think I answered the question.
Yes, sir.
Hello?
Thank you. Sir, there's one more question.
Yeah.
It's from Soumya Matthews. What is the software being used here? I think the question was posted a few minutes back.
Okay. So that software I demonstrated. This is not for modeling. This is actually for slicing the 3D model and preparing the 3D model for 3D printing. Basically, you will software with each printer. Each printer will use its own software. And there are a few 3D printers which uses a common software. So either you can use, okay, let me post it in the chat itself. Here. You can use either Ultimately Cura or so the software I used is Slick 3R, Slicer. That's the software I use for slicing it. And depending on like which software, which printer you have, you will have different softwares. And in fact, if you just want to try it out, you can use this particular software. I will also post the link to this in the chat. This is a web-based slicer software. I'm sharing this link. The chat I'm sharing into only panelists, so I don't have the option to send it to everyone. So panelists, please share it.
Yes, sure. So there's one more question from Avinash. In normal 3D printing, the layers are visible after finishing the project and the finish is not 100% good. Is there any technology to print the object without that visibility of the layer while printing itself?
One of the option is to go very thin, like make the layers, individual layers very thin, and then you can slightly sand it or buff it, or there are few different post processing methods. For example, you can reheat it. You can basically put the printed object. If you are printing in a normal 3D printer, you can basically put this object, cover it with like a fine sand, and then heat it to about 200 degrees. Then these layers will disappear. And if you are printing in ABS, you can use what called acetone bath, and then also you can make the layers invisible. But another thing you can do is like if you are using resin 3D printer, usually the resolution is like really high, so that you won't see. But printer over here, what I told you is the real 3D printer. It's called computed axial lithography. Technology is not yet commercially available, but this printer doesn't. The final object from this printer doesn't have these layers, because we are not printing in layers. We are building the entire object at once. So yeah, this is the only technology right now which doesn't have the layers. Before moving ahead.
No, sir, no.
Hello?
You may continue.
Okay, so now let's see where what's going to happen in future, like with this 3D printing. I'm not an expert in this. This is what I'm going to say from now onwards is basically my opinions, like, and my views based on the experience I have. So you have to take it with a grain of salt. So this is not a 3D print. As we say, this is not a human-made 3D printer. This is in nature. And this is how we were created. We were 3D printed using proteins. And the building block for these proteins were amino acids. There are a couple of types of amino acids, and they were printed using ribosomes, another protein. And this is how we were created. So you can say that we were actually 3D printed like this. The interesting fact is that the property of each, even though every protein is created from basically like a 20 or 20 to 24 amino acids, every protein is different. It does a completely different thing, and the functionality of these proteins comes from the shape of the protein. Okay, and now the reason I'm showing you is this is another one we are creating. What we are trying to do in future is, I think, is trying to mimic the nature in 3D printing, and we are also doing something similar. We are actually utilizing the material properties, which we can call as a fourth dimension. So along with the three physical dimension, the material property is the fourth dimension. So we are printing materials which behaves differently in different scenarios. So for example, if this exposes this material when exposed to temperature, it takes a final. So this is like protein folding, right? You start with something and then you expose it to temperature and then it takes the final form. And even our proteins are the same. When you heat the protein, it loses the function. It just became a long strand of amino acid. And when you cool it, it folds back to its final shape and it shows the. So these are all 3D printed innovative technologies. This is what I mean. This is the new developments in 3D printing. I mean, not the ones we saw till now. We are into material science and we are altering the material properties. It's very interesting properties. So this is a magnetic material. So we are only changing the magnetic field, and this tiny robot is behaving. You can make it crawl through the surface. You can make it walk. You can make it like hold a material. You can make it release a material. Yeah, see. So this is what I think is the future of 3D printing. One of the futures of 3D printing, and then we can also. This is another upcoming technology, which is like you can have like a 3D print with embedded electronics into it. So even though I don't know when it's going to be possible, or even if it is going to be possible, I don't know, but maybe there will be a future where we can just print a mobile phone. I mean, it will be working fresh out of the printer. It could happen, we don't know. So this is something like that. I mean, very close to it. And we use the 3D printer, like for example, concrete 3D printer for creating houses, right? And we are trying to colonize Mars. We are trying to colonize Moon. We are trying to go back over there, and there is no way we can take a big house or construction material over there over to Mars or Moon. And we will have to use what is available in Mars or what is available in Moon. And what is available over there is like a lot of sand and a lot of rock. So you will have to use that to 3D print your own houses. And we already started creating rocket parts. We are already started creating aerospace parts. A lot of things for these industries, and they're like very efficient. You can what you see here is like this internal structure. There is no way we can create using traditional manufacturing methods. This is only possible through 3D printing, nothing else. And we started exploring bioprinting. So for example, we can print organs or prosthetics. So this is another area we are actively researching into. So what you see here is a scaffolding of an ear using a biocompatible material and then infusing it with a real human cells. And then it becomes a organ which is ready to be transplanted into the host. And on this Terminator, but it's going to happen. Not the Terminator, but it's what we will end up in self-replicating machines. So 3D printers that can create 3D printers. For example, one of the 3D printing group called RepRap, Replicating Rapid Prototyper. They were the pioneers into making the 3D printing technology open source and massively available. So their objective is to create 3D printers using 3D printers. And those 3D printers will create another one. So it basically becomes an exponential growth. For example, the company Prusa, they create a lot of 3D printers, and many of the parts for their printers are actually printed using their own printers. So it's kind of interesting. And let's see what what are the advantages and disadvantages? For one of the easiest thing I'll tell you is like I talked about the material wastage. So this is part, right? It's, the side panel of a rocket. You can see that it started with a big block of aluminium, very big. Maybe it weighs about like thousands of kilos. And then they created, they wanted the rocket to be very thin shell, right? You don't want a rocket to be made out of solid aluminium. So the rocket has to be very thin. And if you make it very thin, just like sheet metal, it's going to be, it's going to collapse because the sheet metal don't have a lot of strength. So what you do is like you create these ribs, and the way this milling. So you start with a solid block of aluminum, and then you remove the material to create this. So you will start with a aluminum block which weighs several thousands of kilo, and then you will end up with a panel which weighs like hundreds of kilos, but has a lot of strength. So basically, you will be removing like 99% of the material, and this is very wasteful and very slow. And see, this is the parts required for that. So this all started, and this is 3D printing. We saw this video before. It's creating similar pattern. So you start with the, yeah, see, they are creating similar honeycomb, like these webbings, these ribs, but instead of milling it out, they are actually printing it. So you don't waste material. In fact, you are only using the material you need, and it creates the same material. And I think it could even be very fast compared to the other one. So this will have the same strength as before. So this is where the advantages are. So the 3D printing, so material usage is one of the advantages. Sometimes you will save time. Sometimes you will save time because you can actually you can if you see something like this, removing this material and transporting this material it's a lot of time consuming. So usually, generally speaking, 3D printing is slower than other technologies, but there are occasions where you will save in time and shipping, transportation cost, and like a lot of aspects. Well, sometimes your factory, if you are like a company, you want these materials, you will not have the manufacturing facility in your company. You will need some other contractor to make it and ship it over to you, and that will have a lot of time and cost involved with that. But if you have a 3D printer, you can make almost anything, almost any parts you need. And another advantage is like, see, many of the machines and many of the assembly lines. For example, you take a car, or you take one of the machines in our house. It uses a lot of nuts and bolts and like a lot of individual parts, and then they are all put together. And one of the reason why we had to do is we cannot make it as such, because we don't have the traditional milling methods or traditional manufacturing process cannot reach inside of the object and create that material. But 3D printing can do that. As you can see, this is something like what I'm talking about. There is no way you can create this, and if you want to create this, you will have to start with an outer shell and an inner shell, and then this kind of net-like material, and then you have to combine it all together. But something like 3D printer can build it all at once. So, and what the final is going to be like, you will end up with a lot less parts. For example, if an engine block is going to be assembled from like thousands of parts, maybe you can print it to bring down the number of parts to just a few hundreds. And this will save a lot in assembly cost and in terms of consumables, in terms of individual parts to be assembled, and you will also save in supply chain. Okay, and then another advantage is in prototyping. So suppose you are creating a new product, and you want to just create like hundreds of pieces or tens of pieces just for testing or just for getting feedback from the user. It doesn't make sense for you to create an custom-made injection mold for just 10 parts or 100 parts, because you will be changing it immediately. Like you will create this 100 parts, you take a feedback, and then you will change the design. And each one of this injection mold is going to be costing a lot. So when we have like low volume parts, 3D printing actually saves a lot of money. But 3D printing is not for mass production. If you want like tens of thousands of parts, you don't go 3D printing, you do injection molding. I mean, at least for now. And this is like you see that many companies, they say this machine is out of service, we don't support it anymore, or we don't provide support to it anymore because it's 10 years old or 20 years old, and we don't produce the parts required for that machine anymore. So for example, a washing machine, we could be throwing a washing machine out just because one of the valve is damaged, and it's just a 10 rupee parts, or it's just a like $1 part. Just because we are not getting this $1 part, we have to throw this washing machine out. And this is one of the advantages of 3D. You can actually either design your own individual part and print it, or sometimes even the companies, provided that the company have good intention, they can share all the spare parts as a digital file. Like they don't have to supply, or they don't have to ship the final spare parts to the customer. They can have a database of all the spare parts as a 3D file in their website. So the customer can actually download it and print it whenever they want a spare part. So if done correctly, this will save a lot of machines and a lot of equipments from getting into landfill. So yeah, so this is some of the advantages and disadvantages. And one of the major disadvantages I will say is like the time and the cost for each individual print. So it doesn't make sense to 3D print in large quantity. And this I will talk about during the COVID response. I will talk about this more in depth. So yeah, coming to advantages and disadvantages. So sustainable future is very much related to this topic over here. So we generally have a belief that 3D printing is less wasteful and it's good for sustainable development or sustainable manufacturing. I mean, I agree, but I don't fully agree to it, because when done correctly, 3D printing is very good for sustainable manufacturing. You can actually recycle most of the material. The material wastage is very minimal. Even the wasted material can be recycled. You don't have to ship like a big parts from all over the world to a single manufacturing unit and then assemble it. Instead, you can actually assemble all the parts in-house. So there are many advantages in terms of sustainability. You can have like very efficient designs which cannot be made using traditional methods, and just because of that, our energy efficiency is not very good. But we can use the 3D printer to have very efficient designs. Nozzle over here is it's one of those examples like that. The cooling performance is like really good for this over here. And you can see with this kind of technology, you can have very thin material performing the same, very lightweight material perform the same as very bulky material. Those are really good for sustainability, but then there are disadvantages. For example, if everybody is having a 3D printer in their home or in their nearest makerspace, we are not going to care much. Like as an individual user, we don't care much about sustainability or reuse or recycling, and we end up wasting a lot of material and throwing it into trash bins, and they end up in landfills. And in an industrial scale, it makes sense to recycle each and every component of 3D printing. For example, not just the not just the material 3D printing material, but also all the post processing material. Suppose you use solvents or you use support material and you use chemicals to post processing. In an industrial scale, it makes sense to recycle all of this. But as an individual customer, like as an individual user or like a small makerspace or a small fab lab, we usually just throw it out. And when the 3D printing technology becomes like very much available to everyone, this problem is going to be a lot more. In fact, many of the customers, like many of the users, they, in fact, even I'm sure that the 20 out of the 20 3D printers we are going to do for you, many of them are going to be just like souvenirs or like like models of some cartoon figures or figurines or something not really useful. So this is a problem. Technology like that. But I think it's just because it's a new technology and people don't know what to do, and maybe at the end we will fix it. See, highly integrated products usually something like this is made out of millions of parts or like hundreds of parts, and we are going to, with the 3D printing technology, we are going to integrate into one or two parts. And the problem is, like, with the hundreds of parts, if one fails, we can always replace it. For example, in your engine, if you can always fix a part of the engine, you can always fix a gasket, or you can always fix something. But when you have like a single part which replaced like hundreds of parts, if the manufacturer is if the manufacturer didn't do it correctly, it will result not so sustainable future. It will end up in creating a lot more waste than usual. For example, I will tell you one, like for example, the Apple company recently launched iPhone 12, and they say they are using a lot of recycled material. In fact, they say that this is one of the most sustainably created iPhones in the world. But at the same time, they are against repairing. They create their phones and laptops so that it's very difficult to repair and fix it for yourself. And what this end up saying, like, you will end up in throwing your phone just for a broken display or just for a broken charging port. And this is against what they are doing. I mean, the Apple company is saying that they are for sustainable development and everything, but at the same time they are actually destroying. So it's up to the manufacturer. The 3D printing technology has a lot of potential, but at the same time, if not used correctly, it's going to be very disastrous. We are almost to 1 hour, and I will take a couple of more. So yeah, this is what I'm saying. It's from a quote from the Batman. So it's not what you say or what you like advertise. It's actually what you do. So yeah, COVID response. Coming to the COVID response. So I told you 3D printing is not for making millions of parts. So one of the immediate response from during the COVID crisis was everybody was creating face shields. Everybody was creating masks. And this is not really sustainable because 3D printing is very slow and it takes a lot of energy. It takes a lot of, for example, each one of this face shield, it might have taken at least 20 minutes or 10 minutes for each of them to be printed. That is a lot of electricity cost. So that's not very sustainable. With a lot of machines running just to create this face shield, it's not very useful. This is what we were doing in the beginning of COVID response. We were just creating millions of these face shields. Everybody was creating face shields. It did make sense in the beginning because face shields were like not really they were not in a very high demand, and hospitals were like out of face shields immediately, like during the first month or first week of the COVID. What happened is like the where we could support and where we could step in to support COVID was, you see, during the beginning of year there was a shortage of this material, and the manufacturers who traditionally makes these kind of face shields through traditional manufacturing method, which is injection molding, it's going to be very cheap. For example, if one of this face shield clip, it costed say like $1 for five of them, or $1 for one of them, it would only cost 1/100th of the 1/100th if you do it in via injection molding. But in the beginning, the injection molding company, they were not ready to create like millions of these face shields. So there was a shortage of these, and it did make sense to supplement that shortage. But it didn't make sense to just keep on producing it, because it's not very. And this was one of the German, one of the hospitals in Paris. They just ordered like, each of this machine cost like $50,000 or more. This is from the company statuses, and they just ordered all these printers just to print this kind of object, face shields and the mask. So this was during the beginning of the COVID. And it did make sense to them economically to buy all this machine to print the face shields, because the face shields, when they ordered from China or from the injection molding companies, they were not ready to supply them in the quantities they require in 1 month or 1 week time. These machines were ready in stock, so they just purchased. But what actually makes sense to do during COVID response is like, see, you can actually support the healthcare system when they are in demand. For example, this is for the ventilation machine, and this is a snorkeling mask, and they modified it with a custom adapter and custom valves to use it as a ventilation. Otherwise, you have to insert the tube into the throat. So they didn't have enough, or they didn't have the numbers to match the incoming patients. So this actually makes sense, and they are actually mass producing the valves. Each of these valves actually cost a lot, but it actually costs very little to manufacture it. And the manufacturer of these valves were not ready to sell it in mass numbers for the hospitals, and so each patient require one of these valves, and it was very expensive. So what some of the hackers or makerspace did is they reverse engineered these valves and they started mass producing it. This was one of the useful thing I saw here. One of the thing 3D printing community did for the COVID. It's like we can create spare parts. So if you visit like nearby hospitals or other facilities, you will see that there are a lot of equipments which is just sitting there doing nothing, just because it has a broken knob or just because it has a broken valve, and the parts for these machines are not available, or it might have taken like 1 month or 2 months to ship it during the COVID, because logistics during the COVID was broken, and it was very difficult to get the parts we require. So during such scenario, the 3D printing community can actually support the healthcare system or any other system, actually, not just the healthcare system. Even if you go to like local manufacturing units or like any companies, most of them will have requirements for spare parts. And during the COVID, because of the broken logistics, they may not be getting the spare parts, and the company is maybe sitting there doing nothing. They may be not productive, or maybe the hospital machines are not useful. So we can actually 3D print the parts required to fix these machines, and I think that is one of the greatest or the best thing we can do for the community during COVID. Yeah, so basically that concludes my presentation. And yeah, any questions?
Thank you,
Hello.
sir, for giving us a detailed insight into the world of 3D printing. I guess this was the most interesting workshop we had of all.
Thank you.
So there's a question from Mr. Jayakrishnan.
Yeah.
What about making molds for injection molding through 3D printing? Can mold materials, high-speed steel, etc. part of high-end 3D printers currently?
So yeah, creating molds for injection molding is, yeah, you can actually do it using 3D printed metal printers. So that's one way of doing it. You can actually print in metal, and you can create molds for injection molding parts. Another thing you can do is, like, you can actually create the print itself, the positive, the final object, and then you can use this final object for creating the metallic metallic mold for the injection molding, right? That's another way we can do it. So there are techniques like lost PLA casting, which you can start with a plastic material, but you can finally use this PLA material or wax material to create a final metallic object. So that's another way you can do it. And if you want to create molds for, like, say, silicone or rubber parts, for example, yeah, the valve you see over here, this is a plastic housing, but inside you need a rubber gasket, a special rubber gasket. And these rubber gaskets were actually injection molded in factories. But what these hackers did is, like, they created plastic molds, and they used food grade silicone to create these rubber gaskets. So it's similar to injection molding. So yeah. Did I answer the question?
Yes, sir. Thank you.
Any other?
So I think it's time for us to wind up.
Yeah, sorry, I took around 10-15 minutes extra. So the Fox 3D printing, they are sponsoring about 20 designs. So the first ones to upload these 20 designs will be getting the prints shipped to them. But they were saying design has to be original, which means you have yourself, like, you just don't download it from Thingiverse or somewhere and upload it over here. So you have to design it yourself using any software you want. I mean, if you just download it from Thingiverse, at least try to modify it, like, try to customize it for yourself. It has to be an original design, and then it has to be, like, you have to download one of the software like a Cura or one of the web analyzer I shared you. You try with that software. There are, like, a lot of tutorials available in YouTube, how to design and even how to slice or how to use these softwares. And what you have to do is, you have to make a design such that it can be printed under 2 hours. So if it is a big object, we cannot print that, and it's very difficult to ship it, and it takes a lot of time and material to do that. So yeah, these are the restrictions. It has to be original design, and it has to be able to print under 2 hours. Yeah, that's it. Okay.
Thank you, sir. So I hope everyone got a brief idea of the 3D printing process and its design aspects. Now all the participants are requested to fill the feedback form, of which the link is provided in the chat box. I invite Ms. Ambassador Publications and Project Guidance Team, IEEE PSYP Kerala, to propose the vote of thanks for the session.
Hello everyone, I'm Amita Nair. Aditya, am I audible?
Yes, Amita.
Okay. So hi, I'm the student ambassador of IEEE PSYP Kerala, and first of all, I'd like to thank our speaker, Mr. Shibu Saman, for such an incredible session. 3D printing is quite a great technology, and thank you so much for contributing your time and efforts with us. I would like to thank the whole team of IEEE PSYP Kerala as well as IFSFS 2020 team to initiate such technically advanced workshops, and also to the student ambassadors for their publicity and amazing organizational work. And last but not least, I'd like to thank all the attendees for being such an amazing audience. And I hope that you'll all be part of the upcoming events yet to come. And thank you so much, Aditya, for such a great moderation. Thank you.
Thank you, Amita. Thank you so much. So with this, we come to the end of the fourth spectacular evening of IFSFS 2020. On behalf of the IFSFS team, I wholeheartedly thank all the attendees who have actively participated and shown great enthusiasm right from the beginning of IFSFS. Thanks to our speaker, Mr. Sibu Saman, and all the dignitaries who had assembled here virtually, without whom the day might not have been this wonderful. Thank you all, and we hope for your presence tomorrow for the technical workshop on Introduction to Robo Sanitizer, scheduled for 5:30 p.m. Indian Standard Time. Thank you for making this event a grand success. With this, I conclude and wish for a great time for all. Thank you and goodbye.
Have a nice day.
Thank you.